on the water particles which are in the clouds, and we call these as polar stratospheric clouds. Now, on the surface of these polar stratospheric clouds, whatever HCl we produce, although it is already there, but whatever HCl is produced by the reaction of chlorine monoxide, it reacts with chlorine nitrate to produce nitric acid and chlorine, Cl2. Now this Cl2, it doesn't destroy ozone. So what happens, now if you look back and think about the simulation, so what happened in the Antarctic winter? Antarctic winter is for 6 months when there is no sun. So temperature is low. On the stratospheric clouds, this reaction is going on, and there is a large build-up of chlorine, Cl2. A lot of chlorine is built up during the Antarctic winter. Then comes the Antarctic spring. Sunlight starts to shine, although it's so beautiful to look at the Antarctic, first Antarctic day or first Antarctic night. The first day when sun sets, it sets only for 8 minutes. 8 minutes. So you see the sun going down, it doesn't go completely down, and it again starts to rise. Same is with the first Antarctic day. The sun is about to start because the day is only for 8 minutes. So it hardly comes above the horizon, and it again goes down. So now when this Antarctic spring comes and the sun starts to shine, it brings along with it energy, it brings along with it light. And as chemists, you know that chlorine is a radical reaction initiator because the chlorine-chlorine bond is so weak. So the chemistry at work. So the little bit of sunshine, all that Cl2 which all the winter Antarctica was making and storing low, that chlorine immediately splits into chlorine radicals. And once the chlorine radicals form, immediately the catalytic reaction that we discussed, that starts to happen, and suddenly it is like this, there is something which is heating up the ozone, and from 300 we drop down to about 120, 150 lux centimeters. So that means the special conditions of polar temperatures, formation of polar stratospheric clouds, which lead to the formation of chlorine gas, and with the help of sunlight, this chlorine gas produces chlorine radicals which are ozone destroying, and we get an ozone. So we answered the why. You see that how it happens, but why only about the Antarctic? We said special conditions. So what are those special conditions? Colder temperature during the polar winter, which leads to the ice cloud formation, the acid cloud formation. And then there is another condition which, if you would be interested, we will be discussing, that is called the polar vortex, because all this phenomena takes place high up in the sky. But then, as I said, that there the winds don't blow like this, so there is a circulation of air around Antarctica, and what we call as the formation of polar vortex. So that brings all these chemicals into the lower atmosphere, and that followed by the polar sunrise in the sky. And these conditions are so special that it is really unlikely the scientists would ever have predicted the ozone. So now we know why only about Antarctica. So nowadays, I think major is done with So there are many climate-friendly alternatives. I think that I can skip this. There are many climate-friendly alternatives, and we have prohibited it. We have many protocols, and this is important. What is the effect of the Montreal Protocol, the first protocol that we had in 1987? Then we had the London Protocol in 1990. Then we had Copenhagen again in 1992 and Montreal 2007. So if you look at, if there would have been no protocol, then this would have been our concentration of chlorine, and by now, maybe that the life on Earth might have been almost close to extinction. By all these protocols, now you see this is the level. So that means we are trying to come close to the natural, close to the going back. And this is one example where we can show that if humanity, that means politicians, scientists, policymakers, general public, if we try to come together and work together, we also has the power to bring back what we are losing. The best example is, if you look at the pictures and the paintings of Europe or of the US of the 1940s, 1930s, their rivers were worse than what we have, the kind of rivers or the lakes we have today. You see today, what do you mean? What happened? And the life is coming back again because they mend their life. They brought the life back, those bodies back. So there are further climate-friendly alternatives. So, what is the future of ozone? Now, wonder chemicals, which we said, oh, they are inert, they are non-reactive, and their life is so big, the life cycle is so high, big. So, due to the long span of CFCs, even if we stop using, which the protocols prohibit completely, but still we have not stopped using it completely, still it will take another 50 years before the already released fluorocarbons in the stratosphere. So still 50 साल अभी और लगेंगे वो सारी फ्लोरोकार्बन्स को कि नेचर अपने आप से धीरे धीरे करके उनको कैसे हटाए. And still the use of CFCs are not completely not stopped. And the same ship Magellan Orlandorff, we are doing the mooring, and these are our convoys from the other side. When the ice melts, this is a perma shelf, 900 meters thick ice. So in summary, what I tried to tell you that Antarctica is the key to understand our global change. Ozone is a good example. Ozone is produced and destroyed naturally in the atmosphere. It is responsible for absorbing much of the sun's harmful UV radiation. Ozone hole develops only during its season, that is what we call as the spring, and it is produced by a unique combination of weather and chemistry. That is why I say chemistry, mystery, a mysterious chemistry. So this is a story of notable achievements, discovery, understanding decisions, actions, and verification. And it's a story written by many scientists, technologists. As I said, that if everyone can come together, we can do wonders. So, what I can say, I can only say we live with ozone every day. It can protect life on Earth or harm it. But we have a power to influence ozone's impact by the way we live. And the picture here is a mast in front of Metri, where there is a tradition that whosoever scientist goes, whatever his or her native place is, we put the direction, that all directions are same because South Pole se sab kuch north mein. So we put an arrow pointing to our city and with the exact crow flying distance from that place. So you can see Kurukshetra, 12,309 kilometers from Antarctica. And before that, you can see here Nainital. So I found that who went there. So there was a person from Geological Survey of India who had already been to Antarctica from Nainital, and because Geological Survey of India, they were every year. And look at the distance. I traveled almost 470 kilometers from Kurukshetra. It will be 370 right now. Whole my life I worked in Kurukshetra for 27 years. It's only since 23 that I have settled in the state. So you can see that the difference, I traveled from Kurukshetra, the distance to travel is about 370 kilometers. But here there is a difference, only 1 kilometer, because from Antarctica you only see 1 way. So in the end I will leave you with a beautiful picture and our auto, which is right here. And with a very nice quote by Francis Bacon. The only mistake we do is that we try to master the nature, but we cannot command nature except by obeying. I'm very thankful to you for your kind attention. I'm sorry I shot by 2-3 minutes. I'm very happy to answer.